Okay, log form. I have base B, log base B. So I have log, and my little subscript B is the base. We call that the base, hence the letter B. Now, notice that it's a subscript. If you do not put bases as a subscript, it's going to come out wrong. Okay? Now, notice next to my log base B, there's a y. Now, y is represented what all this time? Solutions, or our answer, right? It's the same thing here. We're going to just call it our solution or number, some number. Okay, that equals our x, which is actually the exponent of the base. Got it? That's log form. Now, this is called our exponent form or exponential form.
You don't take fucking.
Okay, exponential form. Well, we have our base B, and you guys should know this, right? Exponents. B to the x is our exponent. And that equals our y, or our solution, right? Okay, now, just like, will you shut up? Come on, guys, quiet. Greg, quiet. Just like addition undoes subtraction, multiplication undoes division. Guess what logarithms do? It undoes exponents. Okay. Okay. Now, my other two algebra 2 classes did not have a problem with 1 through 7. So let's look at these. I'm going to take the log form, and I'm going to convert it to exponential form. So, looking at number 1, what's my base?
1. Your base is 1.
What's my base?
1.
X, right? It's after the log, okay? So my base is x. What's my exponent?
5.
What does it equal? My y, which is 32. Now, just for the heck of it, does anybody know what x equals here?
I'll find out.
What number raised to the 5th equals 32? 2. Who said that? Way to go, Nate. Well, I'll tell you what. We'll just keep going on, and we'll see if you can catch the pattern. Greg, let's keep going on and see if you could see the pattern. Okay. Number 2. What's my base? We're going to change this into. Okay. What's my exponent?
1.
0.
Zero.
And what's my y?
One.
Oh, I'm sorry, 1. Okay. Is that a true statement? Yes, it is. Anything raised to the 0 power is 1. Okay. All right, number 3. What's my base? What's my exponent? What's my y? True statement? Of course. Anything to the first power is itself. Okay, number 4. What's my base? What's my base? 10.
10. Oh, really?
Wait. Now, this is important because this is going to come back to you in about 3 or 4 minutes here. Is this a true statement? Why? Good. Okay, so
He's heard this class before. That's not fair.
I'm recording this.
Yes, it's true.
Okay, so what's 0.1 as a fraction?
0.10. 1 out of 10. 110.
Okay, 1/10. Now, actually, this is algebra 1 because I just did the unit on properties of exponents. 10 to the negative first, well, it's got a negative exponent. How do you get rid of your negative exponent? No, you flip it. We flip it and make the exponent positive. Now, do you get this? Because I'm going to start yelling at you in about 4 or 5 minutes. No, can't. Because you need to do brain work with this. Okay, number 5. What's my base? What's my exponent?
0. Oh, we're on 5.
And what's my y? True statement? Yes, it is. Okay, again, I have a negative exponent, so I have to flip my fraction, and I'm going to have 2 to the first over 1. Thank you very much. Alyssa. Got it? What's your language? Number 6. What's my base?
My bad.
What's my base?
Base is B.
What's my exponent?
0.
X. We don't know what it is. It's X. And what's my y?
1.
So what is X? X is 0. Very good. Anything raised to the 0 power is 1. So X has to be 0. Yes. Okay. Number 7. What's my base? What's my exponent? X. Which equals B. So what does X equal? Who said that? Way to go, Nate. Anything raised to the first power is itself.
Okay. Now how? X 0.
Okay, number 6. What does B to the X equal? 1. How do I make any power equal to 1? No, it has to have an exponent of 0. Here, my b equals itself. How do I make any number equal itself? Got to have the exponent of 1. Okay, here we go. Are you ready to use your brains? Okay, what's my base? What's my exponent? Okay, this says to evaluate it, so what's my x?
X is 9. Wait. X. 9 times 9.
It's 4. X is 4. Okay, how did Ethan get 4? E to the 4th power is 81. What if you didn't know that? How would you get frickin' calculator, right? You could do it that way, or, yeah, we know we're multiplying it by itself. So if I take, shut up, if I take 3, okay, there's 1 3 times 3, there's 2 3s times 3, that's 3 3s, I know eventually I'm going to hit it, times 3, 81, 4 3s, my x is 4. Shut up. All right, here we go. Stop it. What's my base? What's my base? What's my exponent? What's my y? What's that in fractions? Reduce it. What do I have? 1/25. Good. Now, 5 to the what is going to make 1/25. Now, shh, wait. Remember what I told you approximately 4 or 5 minutes ago. X is -2. Five squared is 25. My 25 is in the denominator. Don't forget, this is over 1. So I have to flip it. And the only way I can make it in the denominator is to put it in as a -2. I see confused looks on people's faces. Are you confused? Alyssa? Huh? You good?
Explain it one more time.
What's 5 squared? What's 5 to the -2? And guess what? Let's look at our problem here. Didn't I ask you? Well, what do I raise? What's the power of 5 if the answer is 125? -2. Got it now? Got it? Got it? Anyone confused? Okay, because it's just going to get more interesting. Number 10. What's my base? What's my exponent? What's my solution? What does x equal? Did you get that, Greg? Anybody see?
One more time.
Anybody?
Yes, because yeah.
Very good. Thank you. Number 11. What's my base? What's my exponent? What's my y? Okay. All right. This should take us another 15 or 20 minutes. Anybody other than Blake and Nate? Greg? Nope. What x equals? 9 to the what equals 3?
No, divided by. No. Divided by the exponent. All right, let me figure it out.
Anybody else have any educated guesses?
Negative 3. Divided by the exponent negative 3. No, it's 1 over 3. 3 over 1. 1 over 3. No. Wait, do you know the answer? Yes, I know the answer. Yes, I do.
Nate, do you know the answer? Yes. 1/2.
That makes no sense.
I knew Blake would have it. All right, so here's what we do. Let's work this backwards. How do I get 3 to be 9? How do I get 3 to be 9? Who said it? Squared, right? Okay. So I need 3 by itself, right? So what do I do to get rid of the power of 2? Square root both sides, right? If I square root both sides, it cancels out the power of 2. So I get 3. Now, think back from last semester. This is radical form. What's the exponent form of square root of 9? Well, we spent a whole section on it. Remember we had like cube root of 9 where and we changed that to 9 to the 1, the exponent over the root. You had it anyway. So what's my root here? What's it called? Square root, so my root is 2. What's the exponent of the 9? So I have 9 to the 1/2. So what does x equal? 1/2. Okay? All right. 2 things you should know. You're like, well, what? Can't I just put this in a calculator and have it figured out and I don't have to use my brain? Well, sometimes, but very few. Mainly because we cannot have log base 1 of x, log base 2. We can't have different log bases of keys in our calculator. It would be gigantor. All right? But our calculators do have 2 log keys. One's called the common log, if you look at your calculators. Okay, see how we have log here and ln here? These are my 2 log keys. Notice, this is called the common log, and this is called the natural log. Now, Notice there's no base printed on here. Okay, if we do not have a base, it's 10. That's called the common log. The common log. See, my base here is 10. Here I don't have a base printed out. The base is 10 here. Okay, it's like an exponent of 1. It's there, but we just don't write it. Okay. So that's why we have a log base 10 key on our calculator. Hey, stop it. Now, yesterday when you did all your homework, we had a continuous compound problem, right? And you learned a new number. What was that number? E, right? E. E is a natural number found in physics and in the planet Earth and the universe and space and all kinds of stuff. Okay, so E is approximately 271. Now, remember what I told you? Remember we were doing stuff like E to the X or E to the 12X and you graphed it? Well, I always told you that logarithms undo exponents. So to undo e to the x, we use the natural log key. Okay? It's ln. That's the natural log. It's the same thing as thinking of it as log base e.
I understand.
So we have two keys on our calculator, the common log that has a base 10 and the natural log which has a base e. Okay? All right, 4 more problems. Okay, I'm going to put an X here, and in fact, I'm just going to put an X for all of these. Okay, number 12. What's my base? What's my base? 10. What's my exponent? And my y is 5. Don't try to figure that out. You'll have brain tumors. Okay, and it's not 2 or a half, okay? Because 1/2 is the square root of 10 and it doesn't equal 5. Okay, I said stop. What's my base for number 13? What's my exponent? And what's my y? Okay, leave it that way for now. Okay, what's my base? What's my exponent? And what's my number? And number 15, what's my base? Exponent? Very good. Do you guys think you can get through this on the homework assignment? We're going to stop here. Your homework. Let's see, you can do problems 12, 16, 20, 24, 28, 22, 24, 28. Yes, you could show me now.